Swayam Prabha. Digital India. Educated India.
Until now we have discussed quite in details origin of soils, their deposition, their transportation, how would you classify them based on different schemes, particularly the geological classification I have talked about, and subsequently I will be discussing about the engineering classification schemes for soils. I have tried to give you an overall picture about what this subject is, what the material is, what we are going to discuss about in this course, why this is essential. So, if you remember last lecture when I showed you the PPTs and I had compiled lot of situations where the knowledge of soil mechanics is required to deal with the situations, and I had termed this as problematic soils, and the way engineers and technologists will take it in today's world is what is known as challenging situations. So, when we study Geotechnical Engineering 1 or Soil Mechanics 1, the whole idea is to understand the material the way we try to understand our friends, our neighbors, our colleagues, and then how to deal with them, how to negotiate with them. The language which we use for negotiation would be, it could be mathematical, it could be physics based, it could be chemistry based, it could be a combination of all those things. In short, how mechanics is used to solve these problems, which you might have appreciated in the previous lecture, this is what the theme of the discussion would be consequently. So, having done the origin, genesis of the soil, how it gets deposited, now today I will be talking about what are the constituents of the soil and what are their properties, because when you try to understand a person or a situation, it becomes quite important to understand what constitutes of this material, what are the constituents of this material. So, today's lecture is based on this theme. This is so I will be talking about the constituents of soils. There are basically three types of the constituents. The first one is the solid phase. The second general category would be the fluid phase. And within the fluid phase, we will have liquids and gases. Don't you think that this system is just like human beings? You see, if you see our body, we have all the three phases, is it not? We have fluid, we have gases, and we have skeleton, bones, which are the solid phase. So, this is a philosophy which I use to define the soil mass and the way the soil technology can be created in another course, not in this course. That means this system consists of solid phase, liquid phase and gaseous phase. Now, what happens is the engineering properties of the soil are going to be a function of all these properties. Is this okay? So, when we talk about the engineering properties, they are going to depend upon all the three phases, that is solids, liquids and gases. Solids are nothing but the minerals, we will discuss about this in details. Liquids are, it could be water, it could be the effluents coming out of different industries in the form of the pollution. The gases could be air, or this could be different type of gases, let us say methane gas, carbon dioxide, a combination of all these things, vapors, water vapors. A simple example would be, if I take a soil mass which is saturated, saturated means the one which is soaked in water completely. If I take it out of the water and put it on an oven, so slowly and slowly what is going to happen is that the soil mass gets dried up. That means what is happening is there is a conversion of fluid phase from one phase to another phase, that means the liquids are getting converted to the gaseous phase, keeping skeleton constant. But suppose if I elevate the temperature so much which is beyond the melting point of the solids, what is going to happen? The entire thing will become, it will melt, it will become like lava. These concepts are being used in today's science and technology when we deal with the soils, particularly radioactive waste disposal, where suppose if I want to remediate the soils which are heavily contaminated, alright. So, what I will do is, I will cordon off some area, I will use laser torches at very high temperature 2000, 3000 degrees centigrade, and I will, what can I do with the soil now? What is this process known as? Known as vitrification, correct, say it loudly. So, this process is known as vitrification. Now, this is a very big scheme which you can follow in today's world. You know, there are not many specialists who can vitrify the contaminated soils, and this is a big challenge in the country. How would you deal with this type of situations? Okay, so let us come back to the conventional thing. The solid phase consists of primary rock minerals, clay minerals, the third one is intergranular cement, somebody was discussing about this in the first lecture, the cementation between the two particles. I think I gave you enough logic also. And the fourth one is organic matter. In modern day application of geotechnical engineering, all these constituents play a very important role. So, it depends upon the way I want to doctrine. You understand what is the meaning of doctrine a material? How I want to, you know, overpower the material, how I want to negotiate with the material, how I want to utilize the material. I can use these phases to solve a given situation. We will discuss about this later on. The second phase is the liquid phase. So, here we have either water or dissolved salts. Now, when I say dissolved salts, these are mostly contaminants. Whenever you get free time, please check it on net. There are a lot of researchers who are working in the field of contaminant transport in geomaterials, alright. In western world there is a big fashion, most of the problems where the industries would like to sponsor research and where they would like to appoint you guys with the knowledge of subject would be mitigation of contaminants in the soils and rocks, which becomes a geoenvironmental study. as far as the gases are concerned, we have air, it could be gases which might produce because of disintegration also of the soils. And why disintegration should occur? Because organic matter is already present here. We discussed about this if you remember. So, organic matter when it comes in contact with moisture, humidity, temperatures, bacterial activity, it might produce gases, clear, and those gases may get trapped into the matrix of the soil and hence this becomes a constituent. We might be having vapors also. One thing you should realize, most of the textbooks deal with the conventional geomechanics, conventional geotechnical engineering, conventional soil mechanics, they are not very contemporary. So, what I try to do here is, I try to give you an idea about the contemporary subject by including the examples or by citing the examples which are going to be useful in understanding the subject in a holistic manner, alright. So, that is the state of the art of the material. Otherwise, there are so many simplifications with which the conventional subject deals with. But now the time has come where all of you should be aware of what is latest. I hope this is one of the reasons why people do not like civil engineering, number 1, why they are not getting jobs, number 2, and why they are not into different areas of activities which they could have done in the best manner, number 3, alright. So, in most of the textbook you will find like this. Now, let me add one more phase, I hope you will agree. If I add, let us say, bioactivity, microorganisms, is this correct? So, this becomes contemporary geotechnical engineering, is this fine? In textbooks you will not find this. So, should I teach all this or not? Any after effect of this? What will happen? Suppose if you know all these things. Microorganisms. When we talk about microorganisms, so as a third year student you can eliminate this part completely, this is just for general knowledge. We have pathogens, you must be studying all this in environmental engineering courses also. Virus, alright. We have bacteria, we have fungi, correct, that also gets transported. So, whenever you get time, please go through their papers and see what type of systems we have been talking about and how do these systems constitute the soils. So, now coming to the primary rock minerals, see these are basically the pieces of rocks which gets disintegrated. Disintegration is nothing but the weathering also, alright, and the attribute is that this would be having several minerals. So, there are few guys who are experts in petrographic examination, I think we discussed about in the first lecture. So, I will take out a rock sample, I will cut a thin sample, mostly in earth science department. What they do is they will make a ultra thin sample and then they will try to study the microscopic feature, the mineralogy, the compactness of the minerals, age, carbon dating and all those things people do. As far as geotechnical engineers are concerned, pieces of rocks which are disintegrated from the parent rock, parent body I will write, which is nothing but rocks, and the diameter of these particles is going to be greater than 2 microns. Is this okay? See, this is how the classification system started, the physics of the material. Another interesting thing is, this is the first time you see we are talking about the dimensions. So, what happens is the primary rock minerals are the ones who guide mostly the engineering properties of the soils. So, these are the ones who are responsible for engineering properties of the soil. We will be talking about different types of engineering properties. How would you compact them, how the water permeates through them, how gases permeate through them, how to consolidate them, what will be the strength of these materials, when do they collapse, and so on. So, here we are more interested in their grading and compactness. Now, sometimes this is also known as skeleton. This is the skeleton of the entire soil system. So, suppose if I am coming from Unilever for that matter, alright, and company asks me to design different type of soaps, lipsticks, different types of cosmetics, alright. So, next time when you use soap, you will realize that this soap is nothing but a multi-phase unit constituting of all this, and in this system I can add one more perfume, plus one more color, plus one more detergent, plus one more durability. So, sometimes soaps melt in the bathrooms, clear, some soaps do not melt. Why? You can do engineering of the matrix of the system which constitutes of mostly rock minerals. We will talk about these details. The second in the series, which is very important, is minerals. Like human body, what is the importance of minerals in human body? I hope you understand. You take food and they say balanced diet would be the diet which has several minerals in it, clear. So, suppose if I ask you to run from IIT campus, let us say extreme hostel number 15 to main gate during summers, peak summers. Those of you who are champions, you can run 25 kilometers, 50 kilometers, 100 kilometers. People like me can run say 1 kilometer, 2 kilometers. Another person cannot run even 300 meters. What will happen? He sweats, clear. And what happens during sweating? Most of the minerals ooze out from the body. Oozing out means they get discharged from the body through skin, clear. And in the process what happens? If I ask you further to exert yourself, you may collapse, clear. The same is the situation in the soil also. Later on we will see. If I do not control the mineralogy, if I do not control the minerals properly in the soil with proper nutrition, with proper water, what is going to happen? The whole system will collapse. And then there is a case like railway track collapsing, embankments collapsing, dams collapsing, and so on, alright. Why? Because the minerals have become altered, or the right minerals are not used, or the nutrition was not given, whatever. You can think of all these things. So, as long as clay minerals are concerned, I will be discussing about this in details in a separate lecture, because as you must have realized from this discussion, clay minerals are the most important thing in the matrix of the soil. So, this we will be discussing separately. Normally, these are the byproducts of chemical weathering of rocks. I hope you understand the difference between the two. The first one, which is primary rock minerals, is a physical process based on only the size, clear. This process is clay minerals are mostly formed because of the chemical process, and this chemistry of the material guides its mineralogy, alright. So, mineralogy is nothing but a chemical form of a material. So, this influences mineralogy. We will spend enough time on this to study. Normally, clay minerals are very small in size. So, the way I wrote here, d is the diameter of the particle, alright, or the size of the particle. Particles need not to be spherical all the time. So, when we talk about the clay minerals, these are not spherical particles, they are going to be needler, alright. So, they will be needles, platelets, mostly, tubes and rods. Incidentally, bacteria is also like that. Are you realizing this? Most of the time the bacteria is also either tubular or in rod form. Now this is a very good interaction, bacteria interacting with the clays, and what happens and why? They have very large surface area, and we call it as SSA. We call this as specific surface area, and this is basically the total surface divided by per unit mass. So, suppose if I assume a cubic structure, alright, this is a basic unit of a structure where these are the particles of the soil, I am assuming them as perfect sphere. So, you can imagine, if you see the front view, you will find there are 4 particles sitting like this, and I can always construct a cube out of it. Is this okay? So, d is some dimension. Now, this dimension could be the diameter in case of the big particles if they are rounded, or this could be platelet. So, I will simply say the length is equivalent to d. So, what I am trying to emphasize is these sizes are going to be extremely small and they are less than 2 microns. So, the first difference which we have created between the different constituents of the soils is based on the physics, clear. The second one is based on the chemistry, and both these things are coming from the weathering process. You take a hammer and start hammering on a big stone. So, what is going to happen? After 1 hour everything will become pulverized, and it is up to me, I can use ultra pulverizers also, and I can crush it to small particles, even less than 2 micron also, nano size particle. Most of the Ayurvedic medicines work on this principle. What do they do? Have you ever seen Ayurvedic doctors? No? They have a pestle and mortar. So, what do? They will put some tablets and they keep on crushing them. Why? The more finer you crush, the more active it becomes. In other words, what I am going to get is, by decreasing the size from here to here, you are reducing the size of the particle, you are making system ultra active. So, this material was a stone, it was a good paperweight for my office. The moment I have crushed it, I have made it nanoparticle size, it becomes what? A medicine. You understand? I can put it in concrete, the durability of the concrete will become 200 years, 2000 years. So, all these Roman people, Roman empires, they were so intelligent. What did they do? They took rice husk, they took bagasse residues of the sugar cane, they incinerated it, and after incineration what happened? These material got converted into ultra fine silica particle, clear, and the moment you put it anything, it becomes hyperactive. So, the cement which they have used 2000 years back, 3000 years back, still the walls are there. Go and visit the entire Rome. Anybody has been there? See, this should be very good. You have been there? Where? Turin? You have been to Rome? Very nice. So, all the structures which you are seeing over there, how many years old they are? Thousands, yes sir, right, and see they are still intact. Why? And we can't make buildings for 50 years even. What is the reason? The basics and science behind the materials is missing. Though we have beautiful SEMs, microscopes and what not, but we are not using the knowledge. Good. So, did you follow something interesting? If I start from here, if I crush it by grinding, there are many companies in India, what do? They take slags from steel industry and they pulverize it to the nano size. They call it as micro cement, ultra fine fly ashes. And what do? They directly add it to the cement. Clear? That is it. It becomes green cement. So remember, the moment particle size decreases, the specific surface area increases. When specific surface area increases, this material is bound to become hyperactive. So what can I do? If I use the right species of the rocks, right species of the minerals, they will be having medicinal value. Metrogel. What is metrogel? Medicine. When you have loose motions, stomach upset, what do? They will give you a capsule of a sort of a mineral. That is it. Okay. So that is what I said. This was a paperweight for me, big size particle. What I am going to do with this? Nothing, just decorate it on the desk. Crush it and see the magic, physical alteration. Alright. I have increased the activity. Now this activity I can do in several ways. Nature does by chemical weathering. In an industry, you can open up an industry tomorrow, collect all the dust which is lying outside your industry, process it by different type of chemicals, and you can produce best possible, best grades of minerals which you can sell in the market. There is a big market in the market, yeah? You can sell it. So I hope you are realizing how nature, what it has done in millions of years, I can do it within few hours, and that is R&D, that is science and technology, you understand? And then I can use it for any commercial purpose. Read, some of you who are interested in opening up your industries, silica reduction technology, SRT, is a beautiful subject to work on. Whatever clays, sands are lying over here and there, if I can process them and if I can take out the silica in a suspension form, somebody was asking about this in the very first or second lecture. If I can take out all the silica from these quartz particles and I can make a suspension, this becomes a beautiful medicinal application in terms of transplantation. I hope you understand. Different type of bone marrow replacements, different types of cosmetics and whatever, wherever they are being used. So this is the scope of the subject. I hope you can understand, a lot of things can be done with this material. It is a magic material. Is this okay? Because we are in the profession, we use it for making buildings, foundations, this, that. Is this part clear?
Sir, when we were talking about that reducing the size of the particles increases their activity. So in specific, what kind of activities are we discussing?
Okay. So the quick answer would be, I would like to use them as chemicals. What is the difference between homeopathic medicine, Ayurvedic medicine and homeopathic, Ayurvedic and allopathic? What is the difference? Quick relief, long term, homeopathic somewhere in between, allopathic immediate and further injection. So whatever suspensions I have taken out from these stones, I will take them out chemically, I will inject in your body, done. I use this concept to treat most of the caves and their statues in the Ajanta and Ellora. This was a beautiful project which I did. I did the dripping of the statues with the calcium silicate. You are getting the point. So micromaterial, it can be injected into any system and this becomes strong system, durability. Is this okay? The second thing, look at your question, repeat your question again, another angle of your question. Yeah.
What activities are we talking about?
Some time back I was talking about the Deccan Trap, Deccan Peninsula, basalt, granite. Over the years what has happened, millions of years what has happened, the weathering is going on in the natural process, dissolution we were talking about, dissolution of rocks. That means this rock got weathered physically, chemical action started. What happened? They got converted to very fine clays, marine clays, they got deposited there, and marine clays have a lot of chemicals into them, chlorides, sulfates, carbonates, bicarbonates, and there is a whole world of microscopic activities which is going on inside. So, now I hope you are realizing that from where to where we can fathom, we can travel. Is this okay? So, normally if I consider this as d is the particle diameter, though this is not valid for fine grained material. Why? Because fine grained materials will not have spherical particles of diameter d, but this is an assumption. So, here the surface area would be 6 times d square. Is this okay? 6 phases of the cube. So, total surface area is 6d square. This surface area is available for the mineral to interact with water, interact with contaminants, interact with environment, interact with fertilizers, interact with microbial activity. So, the more and more surface area you produce, so suppose your fascias you use multani mitti and all, fine particles, bentonite, if I put it over here, what is going to happen? This material has such a high surface area that will take out all sorts of dirt, sweat, microbes, whatever from your skin, and skin becomes fresh. Is this correct? This is a mechanism. So, this is one example I have given you. I have dysentery, I have enough water in my intestine. Use the minerals in right dose, it goes in the stomach, it forms a big gel, blocks intestine, job done. As simple as that. This is fine. So, this is and mass. How to compute the mass of this system? So, volume is known d cube and multiplied by density. So, density of the system would be, I will use the word G. G is known as specific gravity. We will discuss about this later. And to define the specific gravity of the skeleton of the soils or minerals, we will use a prefix as Gs. But after this discussion, I will not use Gs ever for the sake of simplicity. Clear? So, G is the specific gravity of the minerals. So, this thing multiplied by gamma W. What is gamma W? Sorry? This is the unit weight. So, in geotechnical engineering, you have to be slightly careful about this term, because the moment a certain context comes, you will find that gamma W will go for. So, gamma W is the unit weight of water, which is density of water multiplied by G value. Clear? So, this term is density of water multiplied by G. This is the surface area. So, one of the ways to classify the minerals has been based on their SSA. So, suppose if I ask you that there is a mineral like, let us say, montmolonite, which you are talking about, this SSA would be almost 800 meter square per gram. 1 gram of the montmolonite will show you how many meters square of the area. How many of you play football, hockey? What is the size of the hockey field? What is the size of the hockey field? Approximately 900 by 90 by, so 90 into 40, how much? 3600 meter square. This material is 800 meter square per gram of the material, imagine. That means 4 grams of the material is going to show you the same area as of the hockey or football field. Are you getting a feel of it? Did you get a feel of it? In most of our Indian marriages, what do? They have this haldi function, is it not? What is haldi function? In Hindi they call it ubutan. I don't know what do you call this in Telugu, and that means they will use rice flour. They will make a ball of that by adding water, and they simply put it on your skin. Why? This powder is already in the final form. of grains, correct, and you add water, and then this becomes the best possible disinfectant along with turmeric. Got it? This is the basics of the entire thing. It all depends upon you in what profession you are and the way you want to exploit the potential of this material. You want to use this material as a bowler or as a batsman or as a wicket keeper, it's up to you, or as a 12th man. Agreed? This is the number. Most of the current practices in mineralogy are based on this number. When Fukushima accident happened few years back, somebody contacted me and they asked me to convert the material on which I do my research to bring this very close to 560 value, because then they would have used that material directly from India, they would have spread it on their beaches. What for? Good example of surface area. Whatever radioactivity is spread on the beaches, these minerals will simply hook them up, they will not let them go. They become naturally occurring surfactants, cleansing agents. You understand? You got it? I can use them in medicine, more surface area with that 1 gram. What is the size of the intestine? I am sure not 800 meters square for 1 gram of the thing. So, what is the size of the capsules and the medicine which you take? Approximately 1 gram. How much minerals are going to be fed into your stomach? Imagine. And what do? They clog the entire thing. So, the more and more water they come in contact, the more and more water gets parked on them. So, in the next lecture, we are going to discuss about the whole chemistry of this process, electrochemistry of this process. But if you realize that most of the discussion is revolving around the applications part, industrial applications part, and this is where you will see that these two subjects you cannot get rid of. Okay, let us move ahead. So, incidentally, just to give you an idea about the clean sands, have you ever seen a scrubber which is made up of clean sand? The scrubbers, I think you understand. What are scrubbers? See, when your feet become very dirty, what do? Pumic stone. Yeah, so whenever elbows or feet become very dirty, what do? You grind them with this, correct? So, compare this thing with sands. Sands have mostly abrasive effect. There were few detergents which came in the market when you were kid, and hence they were not very popular, but they were very popular because they were very cheap. So, they have most of the abrasive effect in them. Now, by mistake, if you use them for your cleaning your let us say steel crockery utensils, what is going to happen? They will leave a mark. So, they started using soft minerals. Soft minerals are thin platelets, hyperactive chemically. You just put a drop of it and it will clean the entire system. I can use this for cleaning the plates, I can use it for cleaning up of the environment, oil spills which happens in sea, oceans. You understand? Whenever two tankers, when they are bringing oil from different countries and they hit something and there is a spillage or there is an oil slick which is taking place, you must have heard 2 years back off coast of Bombay it happened. How are you going to clean up this system? So, this becomes environmental cleanup. So, from body cleanup to utensils cleaning to environmental cleaning, the concept remains same. Is this part clear? Have you understood? I have given you the clues for the raw material, and believe me, inputs are almost zero, but imagine what you are going to produce is much more costlier than diamonds. So, let me talk about so the logic here is the moment I start crushing them, the specific surface area is going to increase. It depends upon your crushing ability, chewing ability. They say, no, you eat food slowly and chew it properly. Why? To mix it thoroughly with the saliva. When I am making good cements, what should I be doing? Finest particle, mix thoroughly, let it set, beautiful. Extremely, you went to Rome, no? Rome. So, see, extremely durable system I can create. Nothing is going to impregnate through it. Durability has increased, strength is taken care of, system can live ever forever. Okay, so now let us talk about the intergranular cement. So, intergranular cement, mostly these are because of the cementing materials. And what are the cementing materials normally? You know, carbonates, bicarbonates are weak, iron compounds, oxides, calcites. So, other day we were talking about MICP, if you remember, this thing, microbially induced calcite precipitation. So, what bacteria was doing? It was producing calcite which is getting deposited on the sand particles and the soil mass becomes cohesion. This thing appears naturally. Clear? Many times when you walk on the sea beaches, you will realize that what water does to this sea sand. Let me ask you a question. You go to any chapati. As long as the sands are dry, can you run on that? Can you drive a car on that? Yes or no? When it is dry, why? First of all, answer. What is the answer? You have never been to a beach. You can drive a car or not? Why? Material is frictional fully. Take this material and do a simple test. Next time when you go, take 2, 3, 5 grams of the soil and rub it and see what is the friction. That is friction. You have gone to very hi-fi answer. Simple things first understand. What is the difference between dry sands and the wet sands? What water does to the sands? What about the surface tension? Are you getting the hints? So, water in sands make it strong. Why? Because of the surface tension. So, on wet sands, you can easily drive the car or the horse ride and whatever. Clear? So, water acts as a cementing agent, though temporarily. You got it? Now, most of the cementing materials are produced during weathering of rocks, silicates, carbonates, bicarbonates, iron oxides and so on. Depending upon the presence of the cementing agent, we can classify sands. If more calcium is present, it becomes calcareous soil. Alright. So, calcareous soil is the one where you have a lot of calcium impregnation in the sand particles, and calcium carbonate is the deposition which takes place all around the particles, and when two particles come in contact with each other, they become a unit, they get cohesed. So, basically this is deposited on the surface of the particles. Cementing materials or intergranular cements are responsible for imparting strength to the soils. Alright. Later on the second course, we will be discussing it in great details about the effect of cementing of the particles on shear strength characteristics of soils. Tell me one thing, what is going to happen? Suppose if you take an example of calcium carbonate which is naturally existing, and suppose there is an industry which is producing sulfuric acid. Now, what is going to happen nearby on the beach itself? First of all, what acids are going to do to the carbonates? I hope you can understand what human activities are going to do to the soil deposits. So, suppose there is an effluent, a nala, most of the time we do not cover them, we do not channelize the nala flow properly, and this nala is coming, let us say, from different parts of Dharavi and industrial units, Mithi river for that matter. So, what is going to happen? It is containing all sorts of chemicals into it, and suppose chlorides, sulfuric acids, HCl, HNO3, they are too much. What is going to happen? These acids are going to attack the cementing materials which are present in the rock, in the soils. So, what is going to happen? This interlocking of the particles gets dissolved. So, what is going to happen? When rain comes, flooding takes place, excessive discharge from the industries, what is going to happen? Erosion. Is this funda clear? So, whether it is a natural process or this is a man-made process, soil erosion. How many of you can fight a case in the court of law that this is man-made, this is not natural, and hence this guy should be penalized, and this is the penalty on this industry? That is what I do. Got it? So, the more and more industrialization is happening, what we do, people like us, we create a case out of it. We defend governments, we defend individuals. We have a profession. So, I will take samples from that place 20 years back, what happened, today is what is happening. I will prove that this is a human activity. Clear? Because the top layers are only getting affected, the bottom is not affected. This becomes forensic engineering, a big profession which is the need of the hour. So, for detectives, like you do forensic examination, I do forensic examination of different areas. What deteriorated my property? Somebody is going to file a suit, no? Yes. Are you getting this point? The professions are getting generated from the basics. Are you realizing this? Many times, sea water, because of the presence of all these chlorides, sulfates, magnesium, calcium, sulfur, could act as a dissolving agent. We have talked about this in last lecture also, we showed you. So, the moment cementing matter is lost, intergranular cements are lost, finished. Another thing common sense says, as long as the calcium is present in the body or on the soils, what it does? It is a nutrient. Agreed? So, whenever you have deposits of calcium on the particles of the soils, what is going to happen? These guys are going to be there. Is this correct? Fine, because calcium is a source of nutrition. So, most of the calcareous sands are formed because of the microbial activity, okay, naturally, which occurs in the nature, and you will find several examples. I think I have sent you some links also, go through that. This concept was used by our great emperors to make their castles, forts and what not. And over the years, this is not going to get diluted. Why? Because these type of calciums are not inorganic. Their source is organic. So, most of the dams right now in the country are having a serious problem. If you are following the newspaper properly, you must be realizing that most of them are in a serious trouble. Why? They were done 60, 70 years back, okay, and they have not been rehabilitated. So, the big issue is there is a scheme of government of not government, United Nations, where they have funded most of the third world countries to take care of their dams, because if dams burst, what is going to happen? Fine, everything is interlinked. Now comes the organic matter. So, most of the time the organic matter is derived from the plants and vegetation, decomposition of plants and vegetation. Normally in top 30 to 50 centimeters of the soils. Alright. So, this becomes a zone of interest for very few guys. For civil engineers, this is not a very good zone to lay their foundations. Understand? Why? This becomes a layer in which the agriculture is going to prevail better because of the organic matter which gets decomposed when it comes in contact with water, when it comes in contact with atmosphere and so on. But as far as civil engineering is concerned, geotechnical engineering practice are concerned, I will make it sure that my foundations rest. Where is that foundation guy? Yes. So, I will make sure that most of the foundations are going to rest beyond this zone, which is inert. Now, this system is chemically, bacteriologically active. So, this is the delight of any agriculturist, but not for a foundation engineering guy. Fine. Another important thing is organic matters leach. Okay. So, it depends upon what form of the matter is which is leaching. So, this may get washed out, it may get leached due to excessive flooding. Let me ask you a question, how many of you are in favor of making dams and how many of you are not in favor of making dams in your country? Why? Suppose if you have to become an advocate tomorrow, you know Medha Patkar, what she has been doing. Hey, speak it out. She was against. Why? What it has to do with the context of my discussion? See, I have written here the leaching due to flooding. Why? Why I am asking this question? What is the relevance? One issue, social issues, displacement of the people. All right. Number two, no water reaches. So, we will discuss this, that how creation of dams makes adjoining lands barren. So, if the case comes to me to fight, you know, if somebody appoints me as a legal advisor, what I am going to do? I will prove that making of this dam is going to create the lands barren. It is not only the displacement of the people, of course, that is number one, social issue. But more than that, the technical issue is, we will talk about this analysis, that how the water which is percolating through the body of the dam is ultimately going to wash out all the organic matter and the nutrients, because nutrients are going to harp on organic matter. Why? Because of the virtue of microorganisms. Is this funda clear forever? You will remember this? Excellent. So, the point is that the fresh organic waste, when it comes in contact with air and in the presence of bacteria, the decomposition starts. And after decomposition, what will happen? When soils get decomposed, they get converted into humus. You remember we talked about humus, organic matter. Is this fine? Have you understood the whole thing? As a civil engineer, as a geotechnical engineer, I will hate to have this material in my system. So, what will happen? When I practice geotechnical engineering, I will make sure that I will bring the soil to the lab, put it in the oven, get rid of this portion, and then I can control other things better. So, most of the time organic matter is determined by putting the soil mass in an oven, heating it at 100 degree, 80 degree, 70 degree, getting rid of all those things and then analyzing them. Fine.